Hi everyone, welcome back to my YouTube channel. I am Reeti and I'm back with another lecture in the DBMS series. So in the last couple of lectures we learned about different techniques to optimize our SQL queries. In that particular video we heard about a term called as indexing. Now in this particular video we would be learning about indexing and types of indexing. So without any further ado, let's get started. Now the very first question which would be coming to your mind is why do we even need a indexing? So let's take an example of a textbook. So imagine you have a 1000-page textbook and you want to search for a specific topic XYZ. So you are having a book. In that particular book I ask you to search about a given topic XYZ. Now how you can do that? So first thing is, whenever we have the index or the contents of the book, we can go ahead and see that where that particular topic is present and we can go to the page number. Consider a case where you don't have the index which is present in the book. Now in that case what you will do is you will search each and every page one by one. Now there are 1000 pages in the book, so consider the time you would be consuming when you are searching for each and every page one by one. So here indexing comes into picture. So when the indexing is not present, you need to manually search for each term in the book, which could be frustrating and time consuming. Now the second case is when the indexing is present. The index allows you to quickly locate each topic. You can look up for XYZ, find that which is page number where it is covered. This makes it more efficient and less time consuming. So you'll get a range of page numbers. In that particular page number range, you can just go ahead and search for that particular topic. Now here you can see that here you are hardly searching for 2 or 3 pages, but earlier you need to search for 1000 pages. So you can see the search space has also reduced and the time consumed is also reduced. So this is how indexing helps us. So indexing is a critical technique in database management system that significantly improves the performance of query operations by minimizing the number of disk access. Index table is always sorted. Now what does this mean, minimizing the number of disk access? So every data of us is present in our hard disk, or you can say in our disk. Now in this particular disk we have our database. Now in this particular database there are some tables. In that particular table there are some rows, there are some columns, and they are stored in the form of blocks B1, B2, B3, which I discussed in the last video. Now you need to go to each and every block to find a particular topic or a particular key. Now here you can see that when you have an indexing which is present, which says that if you want to search for XYZ, it's present in block B2. So you'll directly go to block B2 and just search for that particular topic or that particular key. Rather than going to each block one by one, you just need to go to one block. So you can see that it minimizes the number of disk access. So the number of disk we are accessing or the number of blocks we are accessing is very much minimized. Now why do we need indexing? So in the same way how we have used indexing in the book, it helps us to find specific records or data entries in a large table or large data set. So consider if you have a large data set in which consider you have 10,000 rows. Now in this 10,000 rows you don't need to go ahead and search for each and every row manually. Rather you can go to the index table and search for a specific key, and then pointing to that specific key you can go to the block pointer where that particular row is stored in the hard disk. So you can go to that particular block. So here you can see that you provide a search key and the data access in the index table. Now in the search key it is used to find the record, and data access, it contains the address where the data item is stored in the memory for the provided search key. So basically we have an index table in which we have a search key and the block pointers or the references to that particular data. Whenever we are searching for any key, it will come to this search key column. It will search for that particular key, then it will go to the block where that particular record is present, and then it will fetch that particular block in the memory. It will search for that particular value. Once it gets that, it will go ahead and send us in the final result. So the search key helps in finding what a user is looking for, and the data access tells us where the record is stored in the memory. It is basically a set of pointers holding the address of the blocks. So all these blocks have some address and that is stored in the index table. Now how the indexing helps? So it helps in improving the query performance. Indexes allows the database management system to locate and retrieve data much more quickly than it could by scanning the entire table. So earlier what we were doing is we were scanning the entire table, or you can say entire blocks in which all the records are present. Now we only need to go to this index table. We need to search for that particular key which we are searching, and then we need to go to the pointing block where that particular value could be present, and then we only need to search for that particular block. So earlier we are searching for each and every block. Now we only need to search for one or two blocks specifically. Now, indexes can be used to optimize queries that sort the data, that is order by, or group the data, that is group by. So as I told in the earlier slides, that index table is always sorted. So whenever we are putting any key which is present in this index table in the key column, they are always sorted. So this is a sorted data. So whenever we want our sorted data or a grouped data, we use index because that is very helpful. So whenever an index is available on the column being sorted or grouped, the DBMS can retrieve the data in the desired order directly from the index, eliminating the need for additional sorting operations. So earlier, whenever you want some sorted data based on some specific column, you need to perform some additional sort operations. But as the index table is always sorted, the key present in index table is always sorted, we can use this index table, or we can use the column on which this particular table is indexed, and that particular column, if we use with the order by and group by clause, it will help me to get my data more fastly and efficiently. Now we have certain indexing methods like dense indexing, where index entry is present for all the records, and sparse indexing, where the index entries are present only for a subset of records in the index. So let's learn about dense indexing and sparse indexing, like how we can store a particular key as well as their search pointers in our index table in different methods. So first one is sparse index. So sparse index is a type of database indexing technique where the index does not include an entry for every single record in the database. Instead, it contains entry only for some of the records, typically one entry per block. So consider that in our database we have some columns where ID is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what we are doing is, from ID 1 to ID 3 we are storing in block B1. From ID 4 to ID 6 we are storing in block B2. From ID 7 to ID 10 we are storing in block B3. So what we are doing is, we are only providing the first element of that particular block in our index table. So here in the index table I have stored all the first elements of different blocks, and whenever I want to search for a value, consider 3, I'll go to this particular index column, I'll see there is a 1 present, and then I'll go to here, I'll see that there is 4 present. So basically between 1 to 4, 3 would be lying, so 3 would be lying in this particular block. So it happens whenever our data is sorted. So whenever we have a sorted data, we can use the sparse index, where we don't need to store the value or store the entry for each and every record which is present in our blocks. Rather, we can store only the first element of the block, and we can give the block pointer where that particular entry is stored in our database or in our disk. So if we need to provide entry for each and every row which is present in our block, it will make the index table a much more bigger table, and then again we need to go through each and every entry, and then only we can search for that particular data. So it will also take more time than the sparse index. In dense index we does the same, we include the entry of each and every record which is present in our table in the indexing table. So in sparse index we only give or provide the entry for, you can say, some specific or single record which is present in each block pointer, so you can say a subset of records. But in dense index we need to provide an entry for each and every record which is present in our database table or the table which is present in our hard disk. Now which have an entry for every record. So dense index have an entry for every record, sparse index have an entry for only single records of each particular blocks, or you can say it contains entry for only some of the records. Now it is used when we have a ordered data set. So whenever we have an ordered or sorted data set, we only use this particular sparse index. If the data set is not ordered, how can I say that I'll give 1 and 4, and if I want to find 3 I can go to this particular block, right? Because the data is not sorted. So when the data is not sorted, we don't use sparse index, but when the data is sorted or ordered, we use the sparse index. So if a table has 1000 rows and it is divided into 100 blocks, you can create a sparse index. The index might have only 100 entries, with each entry pointing to the first record in the block. Now it says that consider our table is having 1000 records. Now these particular 1000 records needs to be stored in the hard disk. So how it will be stored? It will be stored in each and every block. Now consider here it is given that our hard disk has 100 blocks. So how many entries would be there per block? That is number of records divided by number of blocks. So we can say that there will be 10 entries which will be stored in each particular block. Now here we can see that in each block there would be 10 entries stored till 100 blocks. So there are 100 blocks which is present in our hard disk. So there will be 100 entries which would be made in this particular index table, and it would be having the entry for each of the first element which is present in the block. So there will be 100 entries which would be present in our index table. So you can say that each entry will point to the first record in each block. Now let's understand from this particular example that how the sparse indexing happens. So consider that this is my student table. Now in this particular student table, I have the student roll number and I have the student name. So the roll number is in a sorted manner 1, 2, 3, 4, 5, 6, and we have provided the names for all the student. Now what will happen that this particular table needs to be stored in the hard disk. So it will go ahead and store in the particular blocks which is present in the hard disk. Now in the block B1 we have 1, 2, 3. In the block B2 we have 4, 5 and 6. So per block we have 3 records which is stored in this particular hard disk. So how we can create the index table? So what we will do is first we will choose roll number as the index column. So we have choose roll number as the index column. Now we need to provide the search key, that is basically the roll number which is present here. So in sparse index what we do is we don't go ahead and provide the entry for each and every row which is present in our table. What we do is we choose the first element of the block and then we go ahead and provide the entry for that first element. So first entry would be 1 and then we will choose the first entry which is present in block B2, so that would be 4. So we have provided the roll number as the search key and here we have provided 1 and 4. Now we need to provide the access or the data reference where that particular data is stored. So we'll provide the block B1 here as from 1 to 3 all the data is stored in block B1, and then here we will provide block B2 as from 4 to 6 all the entries present in block B2. So this is how we create the sparse index. So how many entries could be there in the sparse index? So it is equal to the number of blocks which is present. So here you can see that there are 2 blocks which are present, so there are 2 entries which is present in the sparse index table. If there were 10 blocks present, there would be 10 entries which would be present in my sparse index table. So it is equal to the number of blocks the hard disk is having. So how sparse indexing actually works? So first is primary index. Sparse indexes are oftenly used with the primary index where the table is sorted on the indexed column. The sparse index only includes an entry for the first record of each block or page. So it only includes the entry for the first row of each block and page, and it is usually done on the primary key of that particular table, so that whenever we index the primary key, that will be always sorted and we can easily find any data value which we are searching for. Now the second thing is searching. So when the searching for a specific value, the database uses the sparse index to quickly locate the block where the record might reside. It then searches within the block to find the exact record. So how searching in the index table happens is, consider I want to search for an entry where the roll number is 3. So I want the details of the student whose roll number is 3. So what it will do is, it will first come to the index table. So it will go to the index table or the sparse index which is present. It will quickly locate the block where we can find 3. So here the search key is 1, here the search key is 4. So 3 would be lying in this particular search key. So we'll go to block B1. We'll go to block B1 here. We will pick that particular block and have it in our memory. And in our memory, we will go and search for this particular block B1 one by one. So there is 1, 2 and 3. Once we have got 3, we will take that and we will return that into our final result. So this is how the searching happens. So here you can see that we only need to search for one specific block. Earlier we were searching for different blocks. So the time complexity has also decreased. So although sparse index is helping us to execute our queries faster and get the results in faster duration of time, minimizing the disk access, there are some disadvantages which is present for the sparse index. Now what are these? So first is additional IO operations is involved. So after using the index to find the correct block, an additional search within the block is required to find the specific record. So when we are searching for a specific key, consider I am searching for roll number 3. If I am going to the index table, I am searching the index table. Wherever I am finding the search key, I am going to the data reference there, and then I am doing a search on the block which is present. So here you can see that there is an additional search which I need to do for that particular block. So because of this additional search, there is additional IO operations which is involved. Now the second thing is less efficient for random access. So if queries often need to retrieve random non-sequential record, a dense index might be more efficient. So whenever we want to do some searches in a set of data which is unordered, then we use the dense indexes. Sparse indexes can't be used there because sparse index generally works on an ordered set of data, because here we are only providing the entry for the first element which is present in our block, right? So here we can't provide any non-sequential or non-ordered data. So whenever we want to perform any retrieval on a non-sequential or non-ordered data, we use the dense index, because dense index has entry for each and every record which is present in these particular blocks or in this particular table. So in that case, we can do any random access for a particular data item. So coming to the use cases, primary indexing on large tables. So whenever we want to perform any primary indexing on large tables where the data is mostly sequential sequentially stored, we can use this sparse index, because the sparse index helps us to fetch our queries in lesser duration of time rather than going to each and every block one by one and searching for data. It's better to go to the index table of the sparse index and then search for the data and go to the pointer and fetch that particular value. So now second one is range queries. So sparse indexes can be effected for a range queries where the query needs to retrieve a range of records rather than a single record. So consider if you want to search for a specific range of record, consider you want all the values or all the roll numbers between roll number 1 to roll number 6. So what you can do is, whenever you are performing any range queries, you can use sparse index, because here you only need to go to 2 rows or you need to only do 2 search operations, right? So here you can see that how fastly you can get a group of data or a range of data when you are using the sparse index. Now coming to dense index. So a dense index is a type of indexing technique used in databases where there is an index entry for each and every record which is present in our data file. This means that the index contains all the search keys and corresponding pointers or addresses to the actual data records, making it highly efficient for direct lookup. So whenever you want to search for any random value in a non-ordered data, you can just go to the dense index, because dense index has entry for each and every record which is present in the table. So you can just do a direct lookup from there. So it is used when we have an unordered data set. So whenever you want to make an indexing in a non-primary key column where the values are also not unique, the data is also unordered, you can use the dense index. Now consider a table with 1000 rows. Now you create a dense index on a non-primary key column, so it can have duplicate values. So the dense index will be having number of non-key unique records, each pointing to a specific row in a table. So consider that there is a non-key column on which you are providing the dense index, and it has some repetitive values, 18, 18, 18, 19, 19, 20, 20. So in the dense index, the number of entries would be equal to number of unique non-key records. So all the number of unique non-key records would be having an entry in the dense index table. So this is how the entries would be made when there is duplicate data set which is present. These are often useful in scenarios where random access to individual records is quite frequent. So whenever we want to do a random access to individual records, we can use this dense index. So here you can see that again we have the student table, and now we are providing indexing on the basis of column, that is age. So since age is a non-primary key column, we can expect some duplicate values which would be present in this particular age column, and here are the names of all the students. So now all these particular data are present in the hard disk, so it will be divided into the blocks. So each block would be having 3 rows. So B1 would be having 18, 18, 19, and then B2 would be having 20, 20, 21. So all 3 records are placed in one block, and these 3 records are placed in another block. Now how we will make the index table? So as I told, that index table would be having entries equal to the number of unique non-key columns. So here are the unique values: 18, then 19, then 20 and 21. So the search key or the indexed column on which we are making the indexing, that is age, would be having 18, 19, 20 and 21, and then we will provide the block pointer. So first search key is 18. So where 18 is present here, 18 is present here, and only block B1. So we'll provide B1 for 18. Now coming to 19, so 19 is present in block B1. So again we'll be given block B1. Then 20 is present in block B2 2 times. So we can provide B2 here. And then 21, which is present in block B2. So we'll provide B2 here. So here you can see that the number of entries which is present in the dense index is equal to number of blocks unique non-key records. So unique non-key records are present in this search key in the dense index table. Now how a dense indexing works? So in a dense index, each index entry includes, first is the search key, the value of the indexed column. The second one is a pointer or address to the actual record in the data file. So where this particular actual record is stored, this particular pointer tells us. Now when a query searches for a specific value, the database uses the dense index to quickly locate the corresponding record. Now consider I want the details of all the students whose age is equal to 18. Now although age is a non-primary key attribute, but since we have indexed this particular column age, it will give me the faster results. So it will come to this particular index table, which is a dense index. It will search for 18. It has got 18. Now it will go to the block B1. It will go to the block B1. It will search in that particular block B1. Wherever it fetches 18, it will take that particular data and it will return that in the final result. So in this way, we can search for any random data which is present in our table using the dense indexing. Now, what are the disadvantages of dense indexing? So it requires significant storage space because it maintains an entry for every record in the table. So in sparse indexing, we were only storing the entry for each first element in the block, but here we are storing the entry for each record which is present in our table. Consider here also we are storing only for non-unique record, but again there are so many records which is getting stored here, right? So the storage is very intensive. Now coming to the next point, that is maintenance overhead is there. So inserting, updating or deleting records require updating the dense index, which can be costly in terms of performance, especially for large tables. So consider in this particular table, now Raghu has turned 20. So we have updated the value of Raghu's age to 20 here, but we need to update it that in the index table as well, because now it will be pointing to a wrong block pointer. Because of this, these particular operations are very expensive. So what are the use cases of dense indexing? First is primary indexing. Dense indexes are oftenly used for primary indexing when the table is small to medium size and quick access to individual records is required. So whenever we want a quick access to individual records, we can use this dense index because it has entry for each and every record which is present in our table. Now second one is exact matching queries. So it is ideal for the situation where the queries frequently request for individual records based on an exact key match. So whenever we want an exact key match that fetch the value of a person whose age is equal to 18. So whenever we were using sparse index, we used to provide the first element of the block, so we need to search for that particular block where the exact entry can happen. But in dense index, we can find the exact entry or exact record in the dense search key itself, so we can find the exact record very easily. Now whenever a query is run, the database engine checks the index to find the pointers to the row that contains desired data. It then retrieves this rows directly without scanning the entire table. So this is our index table. It goes ahead and searches in our index table. Once it searches in our index table, it goes to the block pointer where the data will be present. It fetches the data and it gives us the final result. Rather than going to each and every block one by one, we are reducing the block access which we are doing in our hard disk. Now how indexing works? So it takes a search key as an input and then returns a collection of all the matching records. So consider if I am searching for all the people who are having age 18, there could be multiple people who are having age as 18. So it will search for all the records where the age is 18 and it will return a collection of all the records. Now in index there are two columns. The first one is the one which stores a duplicate of key attribute or a non-key attribute, that is a search key. So search key can either be a key attribute or a non-key attribute in our given table. Now from the table, while the second one stores the pointer which holds the disk block address of the corresponding key value. So in corresponding to each and every search key, there are some block pointers which is stored. Now these particular block pointers point to the address that in our hard disk where this particular data for which we are searching is stored. So in the hard disk, all the data is stored in the form of blocks and we can provide the address of this particular block in this particular column. So we have learned about indexing. Let's learn about types of indexing. So there are mainly three types of indexing. First one is clustered index, second one is multi-level indexing, and third one is non-clustered index. Now in clustered index, we have two types of indexing. First one is primary indexing and second one is clustering indexing. Now when primary indexing happens, so when the key on which we are indexing is a primary key and the order of the data is sorted, we call it as primary index. It basically follows the sparse indexing methods. Now coming to clustering index, so when the key on which we are indexing is a non-key attribute, but the order or the data is sorted, we say that clustering index is present, and this we follow the dense indexing since there is a non-key attribute which is involved but the order is sorted. Now coming to the multi-level indexing. So whenever there is one more level of indexing in the index table, we use inner and outer indexes. So whenever our database is so large or so huge, the index table also becomes bombarded with entries. So we perform one more level of indexing there. We will be learning about multi-level indexing in the next couple of slides. So it is mostly used for large files. Now coming to the non-clustered index, that is secondary index. So whenever the key is a non-key or a key attribute and the order is unsorted, so the data is not in a sorted manner and the key on which we are performing the indexing can be a non-key or key attribute, follow the secondary index there and we follow the dense indexing as an indexing method there. Now let's learn about each and every type in more depth. Distinguish the indexing based on the keys and non-key attribute. Now what they are exactly. So key attribute is a unique identifier for each record. It is oftenly used to distinguish one record from another. So whenever we want to distinguish one record from another record, consider if there are two records R1 and R2, there is an attribute which is present for R1 and R2 which can help me to distinguish between those two records. So that is called as key attribute. Now coming to the non-key attribute, so all the other data in the record besides the key, so all the other columns or all the other attributes beside the key attribute is called as non-key attribute. Now what is the single level indexing and multi-level indexing? So whenever there is only one index table involved, we can say that there is a single level of indexing present. But whenever there are multiple index table involved, like inner index, outer index, we can call as multi-level indexing. So single level indexing is straightforward and works well for a smaller databases, offering a direct approach to speeding up query performance. Whereas multi-level indexing is more complex but necessary for larger databases, as it effectively manages large indexes by creating an additional layer of indexing, thereby improving the data retrieval times. So here an additional layer of indexing is created in multi-level indexing because the databases is very large and have a lot of data which is present in that. So let's learn about primary index. It enhances the efficiency of retrieving records by using their primary key values. So here we use the primary key values of the given records. Now it establishes an index structure that associates primary key values with the disk block address. Now here this is the index structure where we provide the primary key of this particular table. Consider this is roll number, so roll number would be an indexed, and here we provide the pointers to that particular data where it is stored in this particular hard disk or in this particular blocks. Now this index is composed of a sorted list of primary key values with their corresponding disk block address. So this is a sorted data of the primary key values and their disk block address. Now thereby accelerating the data retrieval by reducing the search time. It is specially beneficial for queries based on primary keys. It is done on sorted data. So whenever our data is sorted and we have primary key which is present in our table, and whenever we want to index our primary key, we use this primary index. Now here you can see that there is a search key and the data reference, which is basically the data pointed to the block which is present here, and here we have a student table. Now in this particular student table, roll number is acting as a primary key, so this particular data would be fed in our hard disk. So this particular table will be present in our disk. For the first 3 records it will be stored in block B1, for the next 3 records it will be stored in block B2, and here we have provided the roll number, the name, and different set of data which is present in our disk. Now here whenever we are making the index table, as I told that whenever we are using the sparse index, we only provide the first element of the given block in our index search key. So here we are providing 1 for block B1, and here we are providing 4 for block B2. So here we have provided the address for that particular blocks. Now here sparse index, the number of records in the index file is equal to the number of blocks. So here we have 2 blocks, so there are 2 entries which are present in our index table. So this is our index table which creates an index structure that maps primary key values to the disk block address. So it maps the primary key values to their corresponding disk block address. Let's understand from an example. In a user table with user ID column as a primary key. So here user ID column is the primary key. A primary index on user ID can allow for quick retrieval of user records when you know the user ID. So whenever we know the user ID, we don't need to go ahead and search for each and every block for that particular user ID. Rather what we will do is we will go to the index table, and when we know the user ID, we'll search in the search key, and wherever we find the block pointer corresponding to that, we'll go to that particular block and bring that block in our memory and search for that particular values and get the details easily. So primary index ensures that the database can immediately locate the row associated with a given user ID, making operations like select, update, delete highly efficient. So it makes these operations like select, update, and delete when we know the user ID highly efficient. Now the next one in clustered index is clustering index. So clustering index is generally done on a non-key attribute. So whenever there is a non-key attribute as well as the data is sorted, we use the clustered index. So the data in the table is typically ordered according to the order defined by the cluster index. Mostly each index entry points directly to a row. It is mostly used whenever we are grouping the data. It is physically ordering the records in a table based on the index column. So what happens here is ki consider this is the column age, which is a non-key attribute, but the data which is present in our age is sorted. We can use this cluster index. Now in this particular non-key attribute, we can see that the data is sorted and age is a non-key attribute. Because of that, we can see that there are some duplicate data which is also present. Now this particular table will be present in a hard disk. So first 3 records would be present in block B1, and then the next 3 records will be present in block B2. Now here we have provided the age on which we are doing the indexing, which is a non-key attribute. So age here is 18, 18, 19, 20, 20, 21. Now here we'll be doing a dense indexing, because here we can see that the data is sorted but there is a duplicate data as well as it is a non-key attribute. So we need to do a dense indexing here. Now in the dense indexing, what we will do is we will only provide the entry for the unique non-key attributes. We won't go ahead and provide entry for 18 2 times, 19 1 time, again 20 2 times. We'll only provide for the unique entry. So number of records in the index index file will be equal to number of blocks of unique non-key records. So here we have gone to the search key. Here we have provided the entry for 18, then 19, then 20, and then 21, and here we have provided the block pointers for that particular data which is present in our hard disk. So whenever we want to search based on a non-key column, consider that I want the details of all my students whose age is 19. So what it will do is it will go to the index table, it will search for the search key 19, it has found the 19. Now it will go to the block pointer where it is present, that is B1. Now it will go to B1, it will search for the record 19, and then it will return either a single or the collection of data which is present in our hard disk, or you can say in our blocks. So let's understand from an example for a cluster index. So consider that there is an employee table. If you need to produce list of employees ordered by last name, creating a clustered index on last name can make the queries faster. So whenever there is a non-key attribute, there would be some duplication, and whenever we want to perform any group by operation or order by operation based on a non-key attribute, we can use this cluster index because it can make the queries run faster. Now cluster index keeps the rows in the last name order, reducing the need for the database to perform additional sorting when executing the queries. Now we have performed the indexing on the last name, so what it will do is it will order the last name which will be present in our index table, so we don't need to perform any additional sorting operations. We can use the index table and we can perform the group by or the order by clauses there. Now coming to the multi-level index. So multi-level index is an advanced indexing technique used in database management system to manage large indexes more efficiently. So whenever there are some large indexes or there are large data which is stored in our index table, we use this multi-level indexing. Now when a single level index becomes too large to fit into the memory, multi-level indexing help us in breaking down index into multiple levels. So it breaks down this particular index into multiple levels. So there is an outer index and there is an inner index which is present. So it reduces the number of disk IO operations needed to search through the index. What are the levels in the multi-level indexing? First one is the first level, that is primary index. The first level is the original index where each entry points to a block of data or a page in the table. So the first level consists of original index where each entry points to a block of data or page in the table. Now coming to the second level, that is secondary index. So if the first level index is too large to fit in the memory, a second level index is introduced or created. This index points to the block of first level index, effectively indexing the index itself. So consider that this is my index table. What will happen that there will be one more level of indexing which will happen. Now this particular index table will be having some of the entries of this particular index table because here the data is sorted and there is a key attribute also present. So we'll be following a sparse index and some of the entries will be stored here. So here you can see that we are having an employee table. Now in this particular employee table we have employee ID and the different data of that particular employee. Now here the employee IDs are given and corresponding blocks of them are given here. Now we make the index table. In that particular index table we are indexing on the basis of EID. So we'll provide this EID in the index table and then we'll provide the pointer to that particular address where this data is stored. So we'll be providing the EID as E101, basically the first element of the block, and then we'll be providing the block pointer. Now coming to this block, the first element is E151, so we'll provide B2 and E151. In the same way we'll provide for all the entries which is present in these blocks. So here you can see that our index table is getting bombarded with a lot of entries, and here I have only considered some of the data. In real world there are lakh and crore of data, right? So what we will do is we'll create an outer index, and in this particular outer index what we will do is we'll group the data which is present in this index table, and then for that particular group we'll provide the EID and here the pointer to that particular group. So we have divided it into groups and we have provided the first element of the group, that is E101, then E201 and then E301. So for all these particular groups we have provided an entry, and here we have provided a pointer to that particular entry. So here you can see that we have introduced a new level of indexing and we have indexed the index table itself because the data was so large. So this is how the multi-level indexing works. Now coming to secondary indexing. So secondary indexing speeds up the searches for non-key columns in a database. Unlike primary indexing which uses the primary key, secondary indexing focuses on other columns. So whenever we have other columns apart from primary key, we can use this secondary indexing. Now it creates an index that maps column values to location where the records are stored, making it faster to find specific records without scanning the entire table. Now in the secondary index we basically work on the key as well as the non-key attribute and the data is always unsorted. So whenever we want to work on a data which is unsorted and it can either be a key or non-key attribute, we use the secondary index. So the data is mostly unsorted and it can be performed on both key and non-key attributes. Now here key attribute doesn't only mean the primary key. There are multiple keys which are present in our table. Consider primary key, candidate key, super key. So don't ever consider that if there is a key attribute, it is always a primary key. It can be other attributes as well which is holding some unique values because of which we can find some data. Now the secondary index will be having two cases. The case one is when the search key is a key attribute and data is unsorted. And second is when the search key is a non-key attribute and the data is also unsorted. So let's learn about the first case when the search key is a key attribute and the data is unsorted. So here we have selected age, which is a non-key attribute, and the data is also unsorted. Here you can see 18, 20, then 45, 67, 68, then 22, 24, 30. So here the data is also unsorted and it is also a non-key attribute. So it is now stored in the blocks which is present in our hard disk. Let's understand it how the indexing will be done in this particular case. So here we can see that age is having an unsorted data, so we can use a dense index, and in this particular dense index what we will do is we will provide an entry for each and every record which is present in our table. We have to just make sure that that entry should be unique. There shouldn't be duplicate entry which should be present in our index table. There should be only unique entries which should be present. So we'll go ahead and provide these particular entries in our index table. But the best thing about the index table is that the index table is always sorted. So it will go ahead and it will enter the data in a sorted manner. So search key will be present in a sorted manner, and then there will be a data reference or the block pointers to that particular search key. So here we have followed a dense indexing where the number of records in the index file is equal to number of blocks of unique key records which is present in this particular case. Now coming to the next case when the search key is non-key attribute and the data is unsorted. Now here age is a non-key attribute as well as the data is also unsorted. So here you can see what is happening. Age is 18, then 20, then 67, then 22, then 22, 24 and 30. Here you can see that the data is also unsorted. There are some duplicate datas and it is a non-key attribute. Now in this case how the indexing will happen. So here we can see that the 22 is happening in block pointer B1 as well as in B2. So how we will mention that in our index table. So what we will do is first we will provide the entry for each and every unique non-key record in our index table, and whenever we find that for a unique non-key record there is some entry which is present in B1, B2 or different blocks, what we will do is we will represent it in the form of a linked list. So what we will do is in the data reference column we will provide B1 and then the next occurrence of this particular 22 in this particular block, that is B2. So we'll provide it in a linked list manner or in a linked list fashion. So this is how we provide the search key which is always sorted in our index table, and this is how we provide the data reference. So here in the dense indexing the number of records in the index file will be equal to the number of blocks of unique non-key records. Here we have discussed about almost all the types of cases when we have a key data but the data is unsorted, when we have a key data but the data is sorted, when we have a non-key data but the data is unsorted, when we have a non-key data but the data is sorted. So we have discussed on all these cases. Now we will be discussing on how we can create indexes in our databases. So how to create indexes. So we can create indexing based on one column or multiple columns. So let's see. First we'll see that how we can create non-cluster indexes, basically secondary indexes. So when we want to create on one column, so we give this command create index followed by a name which we provide to the index, and then we provide on, then the table on which we are creating the index, and then the column on which we are creating the index. So this is for one column. On multiple column we give the same command create index followed by index name, then on, table name, and then we provide the different columns in comma separated way. So this is how we create in non-clustered indexes. Now when we want to remove an index, we give this command drop index, then the index name, and then we provide on, and then we provide the table name. Now coming to the clustered index, so it automatically gets created with the primary key. MySQL does not support explicit creation of additional clustered indexes. So MySQL does not support any additional creation of clustered indexes. It automatically creates with the primary key itself. So this is all about indexing and types of indexing. I hope you like this video. So if you like this video, please hit the like button. If you're someone who is new to my channel, can go ahead and watch out the tech content first. And if you find it useful, can go ahead and subscribe. Also, if you have not followed me on my social media handles, you can go ahead and follow. The links are in the description. Till then, take care, keep learning, keep growing, keep smiling. Bye all.